So let's go for now exercise 13.1. But before I start this exercise, let's recall what we did in earlier sessions. The one was definition of limit. Limit x tends to a, fx equals to L. You know meaning of this very well. This means whenever x is very nearby a, then function is very nearby L. That's one thing. And from there we had two limits. Limit from right of the function and limit from left of the function, which also we have discussed. This means x is very close to a, but x is chosen from right side. So x must be greater than a here. This means x is very close to a, but it is chosen only from the left hand side. So x is less than a here. That's a concept of right and left hand side limits. You know, these two limits need not be equal. If these two are equal, then that number is called the limit of the function. Your L is any number, remember. And you know, whenever limit exists, then it is unique. Whenever L exists, L means limit, then it is unique. Then it is unique. Unique means exactly one. If limit exists, then it has to be one and only one. Function cannot have two different limits, remember. Okay. Then we had these formulas, if you remember, you can call the results. Limit of constant is constant. Limit of a power function x raised to a, x raised to n equals to a raised to n. Power function. X is replaced by a. Your constant, constant. Then one more, that was limit x tends to a. If you have polynomial upon polynomial, then what you need to do? You see that if you have 0 by 0 form, place the value of x. If you have this form, then factorize this. One factor must be x minus a. So x minus a into some expression upon x minus a into some expression. Cancel it and now apply the limit. Apply the limit means what? Instead of x you put a. Next form, that is that standard form, x raised to n minus a raised to n upon x minus a, that is equals to n into a raised to n minus 1. This is the limit. What you did? Take this n in the product and one less power here. N in product and one less power. Then the one more, that was about trig functions. Limit always x tends to 0. If you have sine x, then same angle should be there. Then this expression is very close to 1. And same thing is for, remember, tan. So if you have tan x upon x, three things. This angle and this angle should be equal, and that angle should be close to 0. Then the limit is again 1. Right? Okay. One more. Here it was sandwich theorem. It was, that sandwich theorem here. That's for special inequality. Fine. Now, one more thing which I now state, you need to remember that if any limit question has one of these four factors, 1 plus or minus cos x or 1 plus or minus sin x, if you have one of these four factors, take conjugate. Take conjugate. What do you mean by conjugate? Multiply and divide with the same factor with opposite sign. You will see once I discuss the examples. What? If you have 1 plus or minus cos or 1 plus or minus sin, take conjugate always. Fine. If you have 1 plus or minus cos or 1 plus or minus sin, take the conjugate. And then continue further. You can solve this. And the second thing, if you have root expression in limit question like this, plus or minus some constant, or if you have like this, both the places your root plus or minus one more root like this, then again you do the same thing, take the conjugate. If you take the conjugate, what's a conjugate? Multiply and divide the given question with the same expression with opposite sign. Right? Now we already studied complex numbers, so you know conjugate. Same expression with opposite sign. So this much we'll use in the next exercise. These are the concepts, remember, which we'll use. So now if you read the question here, evaluate the following limits in the exercises 1 to 22. So question number 1, first question. Limit x tends to 3, function is x plus 3. This is very simple function, linear function, our first example. So you can use working rules. You can apply the limit inside the bracket. Limit x tends to 3x plus limit x tends to 3 of 3. What I've used? Just taken limit inside, working rules. What I did? Just taking limit inside, first working rule, you know it. Now as x tends to 3, x is 3. Limit of the constant is constant, so this is just 6. So the limit of this expression is 6. What it says? You know it now. Whenever x is very close to 3, then this function is very close to 6. Fine. This is a simple question, just substitution. Question number 2. Limit x tends to pi. Function is so simple, x minus 22 by 7. X minus 22 by 7. So just place the limit here because this is again very linear function. So you have pi minus 22 by 7. Right? You know this is approximate value of pi. So if you want, you can just place the 0, approximately 0. Otherwise, you can leave it in this form also. Right? That's not important, remember here. Just you place the limit directly, which is important. Third sub question. Question number 3. Limit r tends to 1 pi r square. Pi is constant here. Limits depends upon what? R. So I can take pi outside. So you have limit r tends to 1 r square. So place the limit now. Place the limit means what? Instead of r you put 1. So 1 square. So final answer is pi. Okay, which formula you have used indirectly here? Limit x tends to a, x raised to n equals to a raised to n. Now we are not using tabular form, we are using results. We are using formulas here. So instead of x, I have placed a. So r की जगह पे 1 कर दिया. When you place the limit, only one thing you need to be careful. You should not have 0 by 0 form. ऐसा form नहीं होना चाहिए. Otherwise, always you can place the limit. This we say that we have placed the limit. Fourth question. Question number 4 here. That's polynomial upon polynomial form. Limit. What we have here? X tends to 4. 4x plus 3 upon x minus 2. So we apply the limit to numerator as well as denominator. This is just beginning, so I'm showing. If you remember, this is that last working rule, division rule. When we can apply the division rule, denominator limit should not be 0, and it is not 0, you know. Now we apply the limit here. So instead of x, we put 4 here. So 4 into 4 plus 3 upon 4 minus 2. Fine. So just simplify. So what we'll get here? 16 plus 3, which is 19. And there you will get 2. So this is just 19 by 2. Right? Again, I'm just reminding you, what's the meaning of this? Whenever x is very close to 4, then this function is very close to 19 by 2. That is what we understand by concept of the limits, remember. I repeat, what we understand by this, whenever this function is whenever this number is very close to 4, then this function is very close to 19 by 2, and that is declared as the limit of the function. Why we could apply the limit here? Because we are not getting this form. 0 by 0 form नहीं आ रहा है, remember. अगर ये आ गया तो it is undefined. So you need to use something else then. You cannot apply limit directly. Next question, fifth one. There are some elementary questions. Limit x tends to -1, x raised to 10 plus x raised to 5 plus 1 upon x minus 1. Now apply the limit and check whether you are getting 0 in the denominator or not. So if I apply the limit, you will not get the 0 here. So I'll drop this step. I'll apply limit directly to numerator and denominator. This is -1, this is -1. -1 raised to 10 plus -1 raised to 5 plus the limit of the constant is constant. What I did, I applied the limit. Okay, what is this? This is -10. Sorry, this will be +10. This is -5 plus 1 upon -2. So you have here 11 by 11 minus 5, which is 6 by 2. So you get finally I'm sorry, this is my mistake. This should be, 1 here. This should be -1 here. This is +1 upon -2. So you'll get the -1 by 2. This was my mistake. Just here -1 raised to 10 is 1, -1 raised to 5 is -1, this 1 as it is. So -1 by 2 is limit. It means whenever x is very close to -1, then this function, this is the entire function, which is very close to -1 by 2. That's required limit here. Next question. Question number 6 here. Sixth question. Limit x tends to 0. We have x plus 1 the whole raised to 5 minus 1. So you must realize now which formula should be used. You have power here, remember. And secondly, if you apply the limit, you see you'll get the 0 directly. So directly limit should not be applied. Now when we have power, we just recall this formula. Which formula? X raised to n minus a raised to n upon x minus a. Fine. Without powers, expressions are same. Now if I drop the power, expression should be same. So here x plus 1 raised to 5 minus here 1 raised to 5. It is 1. I'm trying to set this formula. Now drop the power. तो नीचे क्या होना चाहिए? x नहीं चलेगा. x plus 1 minus 1. What I did? I've set the formula. मैंने ये formula के form में set किया. How? By adding and subtracting 1. Got it? Now you see this both look same. X plus 1. This is like x. So x raised to 5 minus 1 raised to 5 upon x minus 1. Have you realized what I did? Just have set the formula. Without powers, numerator and denominator expression same दिखना चाहिए. So अब दिख रहा है. Just have added and subtracted 1. Secondly, यहाँ पे जो नंबर है वही यहाँ पे होना चाहिए. यहाँ पे तो x tends to 0 है. अगर x 0 के पास जा रहा है तो x plus 1 किसके पास जाएगा? Tell me. Obviously 1 के पास. तो I can write like this. ये आप ना लिखो तो भी चलता है. If you realize what I did now, I've set the formula. Now, what is the limit of this? Answer to this here, n into a raised to n minus 1. So, what we'll get here? 5 will be in the product. 5 into 1 raised to 1 less power. If 5 आगे आ जाएगा, 1 as it is, और इसके less power. So, 5 minus 1, which is 4. So the final answer is just 5. What's the meaning of this? It means whenever variable x is very close to 0, then this function is very close to 5. This is just for your information. You take x equals to like 0.0001. This is very close to 0. Put into the function here. Plus 1 do raised to 5 minus 1 upon 0.0001. Simplify this. You'll get a number like this, 4.999 or 5.000, something like this. I mean, this number will be very close to 5. You can see that if you want, just by calculator. But this is by formula. No way we are using the tabular form. That's what I'm trying to tell you. Fine. I've used this formula. I hope this is clear to you. Let's see one more question like this. Suppose I have limit x tends to, let's try 0 here. Suppose I have here, let me write, for example, x plus 2 here, the whole raised to 3 minus, let's write 8 upon x. Suppose I have this. Now you have raised to 3, so you can write like this here, limit x plus 2 upon, see here, if I drop the power, this 8, of course you can write 2 raised to 3, you must have realized. Now if I drop the powers, ऊपर नीचे same expression दिखना चाहिए. तो नीचे क्या दिखना चाहिए? x plus 2 minus 2. Have you realized what I did? I've added and subtracted 2. Here it was just x. Now drop the power, you see your same expression, both the places your minus sign. And I needed 2 here. So what I'll do, if x is close to 0, x plus 2 is obviously close to 2. If x is close to 0, then obviously x plus 2 is close to 2. Now it became, ये आप change ना करो और लिखो तो भी चलता है, but important one is this changing, remember. Okay, now it's a formula. Which formula? X raised to n minus a raised to n upon x minus a. Then what's the limit? You know the limit, n into a raised to n minus 1. So this 3 will be in the product. 3 will come in product into 2 raised to 3 minus 1, which is 2. So what we'll get from this? This is 3 into 4. So your final answer will be 12. So this function is very close to 12 whenever x is very close to 0. I hope now this is clear to you. Okay. Let's see next question now. Which number next? Question number 7. By writing the question, you must realize it is with standard form, remember. Limit x tends to 2, your 3x squared minus x minus 10. This is polynomial. In fact, it's a quadratic. X squared minus 4. This is which form? Polynomial upon polynomial. Or more precisely, quadratic upon quadratic. How do we solve? Put the limit here. So 4 minus 4, 0. Put here also. So 4 into 3, 12. Minus 2 minus 10. 12 minus 12, which is 0. So 0 by 0 form. Can we apply the limit directly? No. 0 by 0 is not defined form. It's undefined form. So what we do? We factorize. Which factor you must have in the numerator and denominator? X minus 2. Always this minus this. If I have suppose x tends to minus 3, so my factor will be x minus minus this. So in that case, the x factor will be x plus 3, remember. So here you must have which factor? X minus 2. Here you can see clearly x minus 2 into x plus 2. What about here? I'll directly write x minus 2 as a one factor. And now I'll set here. How do I set? 3x. So 3x squared. And I need here minus 10. So I must write plus 5, I suppose. Factorization, 9 standard or 10 standard. Simply factorization. Now you just open, you'll realize 3x squared plus 5 minus 6. So minus x and minus 10. This is simply factorization. Nothing big mathematics. Now this will get cancelled. We are left with this much. Let's try it one more step. So we are left with this 3x plus 5 upon x plus 2. Now this is like question number 4. The fourth question jaisa ho gaya. Apply the limit now. Again you should see that there should not be 0 by 0 form. I'm applying the limit. As x tends to 2, I'm putting 2 here. 2 plus 2, 4. Here 3 into 2, 6 plus 5. So what we'll get here? 11 by 4. That is a required limit. 11 by 4 is the required limit. What is the meaning of this? It means whenever x is very close to 2, then this function, this is a function, is very close to 11 by 4. Fine? Okay. Next question. Question number 8. Limit x tends to 3, x raised to 4 minus 81 upon 2x square minus 5x minus 3. This is which standard form? Can you recall? It's which standard form? Polynomial upon polynomial. So check whether you have 0 by 0 form or not. So I'm putting 3 here. So 3 square, 9 into 2, 18. 15 minus 3. So again 18 minus 18. So which is 0 by 0 form. Just you can check. So this you cannot evaluate directly. What you need to do? You need to factorize. Which factor you must have in the numerator and denominator? X, this minus this, that is x minus 3. Now here, this 81 you can write as 3 raised to 4, you know. Now how do we do this? This you can write like this. X minus 3 into x plus 3 into x square plus 3 square. You know it. I'm just showing you. What I did like this. X raised to 4 minus 3 raised to 4. So x square minus 3 square into x square plus 3 square. Fine. And then this cannot be factorized, you know. इसका factors तो complex numbers में होता है. क्या होगा आप सोचो. What are the factors? This in turn you can factorize. Into this factorization is not important for us. Right? Important one is this one for us. That's what I wrote directly here. Now, here you know factor, एक factor x minus 3 होना ही चाहिए. If it is not there, the question must be wrong, remember. It has to be. If it is 0 by 0 form. What about this here? I need 2x square. So I must have 2x. End में मेरे को minus 3 चाहिए. तो it must be plus 1. This is simply factorization. Whichever way you like, you can do it. Now open the bracket. 2x square plus x minus 6x. So minus 5x minus 3. This will get cancelled. So we are left with limit x tends to 3. X plus 3 into x square plus 9 upon 2x plus 1. Now you can see that this is not 0 by 0 form. So just place the value. So I'm applying the limit. Place the value means applying the limit. So 3 plus 3 into here 9 plus 9 upon 6 plus 1, which is 7. So you just simplify. You will get 108 by 7. That's required limit of the given function. Question number 9. It's too trivial question. Limit x tends to 0. Just reading the question now you can answer. We did 8 questions. So you must have realized now how to do such questions. Tends to 0. This is polynomial upon polynomial. You know it's a linear upon linear. So just place the 0 in the denominator and see whether it is 0 or not. I'm putting 0 here. So 0 plus 1. Here you have 0 plus b. What I did? I've applied the limit. Instead of x, I placed the 0. A into 0, 0. B being constant as it is. C into 0, 0. 1 being constant as it is. So what's your limit? Just b. So whenever x is very close to 0, this function is very close to b. Fine? Okay. Now, next question. What about next? Question number... let me do 11 first. There it is just application of limits. Limit x tends to 1. ax square plus bx plus c. This is quadratic, or you can say that this is which form? Polynomial upon polynomial, right? It is which standard form? Polynomial upon polynomial, or you can say quadratic upon quadratic. Apply the limits directly, because you will not get the 0 by 0 form. So a into 1 square plus b into 1 plus c upon c into 1 square plus b into 1 plus a. So you will get the a plus b plus c upon a plus b plus c. So you will get just 1 here. The limit will be 1. Both will get cancelled. So function will be very close to 1 in this question. Let's go to previous 10th one. That is really good question. Right? By looking the question, you must have realized what should be done. You have powers, remember. So limit x tends to 1, z raised to 1 by 3. Sorry, here z tends to 1. Variable is z here. Minus 1 upon z raised to 1 by 6 minus 1. Can we apply the limit directly? Dekho. If I apply the limit, 1 raised to anything is 1. 1 minus 1, 0. 1 raised to anything is 1. 1 minus 1 is 0. So you are getting 0 by 0 form. Now which formula we have in our mind? This formula. X raised to n minus a raised to n upon x minus a. This is what we have in our mind once we see this question. Okay. So I'm just rearranging, you see. Limit z tends to 1. This is z raised to 1 by 3. Instead of 1, I can write 1 by 3. 1 raised to anything is always 1. Upon here, this is z raised to 1 by 6. Instead of 1, I can write 1 by 6. Now, in the denominator, you must have x minus a. So, in the denominator, I must have what? In the denominator, here I must have what? Without powers, that is z minus 1. यहाँ पे भी upon z minus 1 होना चाहिए. So what I did? Dividing numerator and denominator by x minus 1. Dividing numerator and denominator by z minus 1. Not x minus 1, z minus 1. And one more thing. I'll apply the limit to numerator and limit to denominator. You see, I did number of things here. Working rule. Which working rule? Last working rule. Division rule. ऊपर वाले को लिमिट लगा दो, नीचे वाले को लिमिट लगा दो. ये क्या क्या? जस्ट टू सेट द फॉर्मूला. इतना होना ही चाहिए नीचे. z minus 1 should be there, z minus 1 should be there. अब देखो how many different formulas? 2 different formula बन गई. What is the limit to this? Take this power in the product. 1 raised to 1 by 3 minus 1. That's the answer. N into a raised to n minus 1. You know very well. Upon, what about this? 1 by 6, 1 raised to 1 by 6 minus 1. Power is reduced by 1. Power is reduced by 1. Remember. This is 1, this is 1. So this is 6 by 3, which is 2. So limit is 2. Fine. Clear? Is this clear to you? Here, 1 की जगह पे same power लिख दिया. That's one thing. फिर आप ये जानते, you should have upon x minus a. So I should have this. So dividing numerator and denominator by z minus 1. And I've applied limit to individual functions. So I'm getting this just by simplification. Single formula 2 times. It's like this. Let me do one more here. You will just realize. एक और question आपके लिए कर रहा हूँ यहाँ पे. Let's see this. Suppose I want to evaluate this. Limit x tends to, let me write 1, x raised to 19 minus 1 upon x raised to, let's write 6 minus 1. So how do I do this? You have such powers. So what I'll do, x raised to 19, instead of 1, I'll write 1 raised to 19 upon here x raised to 6, instead of 1, I'll write 1 raised to 6. Then what should be done? Without powers, you must have the expression. So I must have without powers x minus 1, without powers x minus 1 and apply the limits to numerator. This is the last working rule, and the limits to denominator. Fine. Now, what about this answer to this one? You know it is 19 1 raised to 1 less power, which is 18, upon this is 6 into 1 less power, which is 5. These both will be 1, so it is just 19 by 6. Fine. I'll give you one more question. One more here for you. Try yourselves, and you submit me when you submit the homework. Limit x tends to minus 1 x raised to 2019 plus 1 upon x raised to 2013 plus 1. Try this. This for you. Nothing. It's not big task. I'm sure you can do it. Right? So this is for you. Do it. You can predict the answer also from the beginning. I'll not give you the hint. Just observe this question. What is answered here? Here. This is simplification. And just observe this. What is the answer here? You can predict the answer. This is just one marker. By observing the question, you can answer. Not a big task. Try. Okay. Now, let's continue with the next question. 12th, 11th we did. 12th, I'll leave it for you again. I'll not do it. Try. There is nothing. It's too trivial question. Okay. We go to now question number 13. 13 onwards we have questions about trigonometric functions. So when we solve 13 onwards, we need to keep these two formulas in our mind. In any limit question, trigonometric function is involved, then one has to use this or this. Remember, 99% questions can be solved with the help of these two formulas. Both limits, both are 1. In any limit question, trigo is inward, then you need to keep this expression in your mind, or reciprocal, x upon sine x. 10x upon x tends to 0, tends to 0. This angle and this angle should be same. This angle and this angle should be same. Fine. Now we go to question number 13. Let's see, you will realize these are very interesting questions. Sine ax upon bx. Fine. Now what about this b? B is not important for us. It's a constant. So I'll keep 1 upon b outside. Here, limit x tends to 0. Tends to 0 hona chahiye, remember. Your angle should go to 0 always. Now what is angle A here? What is angle A here? That's a sine x. So here A sine x. So denominator mein kya hona chahiye? Same angle hona chahiye. You have only x. So I'll divide by A and I'll multiply with A. Multiplying and dividing by A. Angle should be same. This is ax, so here also ax. If you want, you can write as x tends to 0, ax also tends to 0, but that's okay. If you want, you can write like this, one more step. A constant, b constant, so I'll keep a by b outside. Here, you can keep this, or if you want, you can write ax tends to 0. If x is very close to 0, obviously x will be very close to 0. Sine ax upon ax. Now what is the limit of this expression? As per this formula, it is 1. So a by b into 1. So your answer is just a by b. Which formula you have used? Limit, you can write theta tends to 0, sine theta upon theta. A dono same hona chahiye, that's I'm emphasizing. Or a angle 0 ke paas jana chahiye, then the limit is 1. That's what this formula and this formula says. Fine? Okay. Question number 14. So let's see 14 number. So there you have limit x tends to 0, sine ax upon sine bx. Here, you must have the same angle in the denominator. Now angle is not there, so what do? We write upon ax, and here into ax. We have just set multiplying and dividing by ax in the numerator. Now the whole upon is already still pending. What about this? Sine bx. I need bx, so I'm writing by bx, so I need to write into bx. और ये क्या करेंगे? As we did earlier, we apply limit to both individually. This is the last working rule. Limit to numerator function, limit to denominator function. I hope you must have realized what I did. I've just set the angle as per our requirement. Here angle is ax. I need ax. So into ax. I need bx, so by bx into bx. Now what is this? This gives us 1. What is this? This gives us 1. ये दोनों cancel हो जाएगा obviously. This is 1 into a. This is 1 into b. So the required limit is a by b. A by b is the required limit. Okay. So in the question number 14, the required limit is a by b. Let's go to question number 15. The 15th number, you have limit x tends to pi sine pi minus x. So here angle is pi minus x upon pi into pi minus x. Now this is constant, and you know one of the working rule, constant always you can take outside. So what I'll do, I'll take 1 by pi outside. That's not important for us. You know this. This is that second working rule. You can take constant outside. Now this is sine pi minus x upon pi minus x. So angles are same. See? Sine theta upon theta. And theta should tends to 0. But that's obvious because if x is very close to pi, what about pi minus x? It has to be close to 0. So ये एंगल जो है पाई माइनस एक्स वो 0 के पास जा रहा है. यहाँ पे दिख नहीं रहा है, but it is there, remember. So 1 upon pi as it is. What's the limit of this expression now? You know it is just 1. According to which formula? This formula. So the limit is 1 upon pi. Okay. No need to put the value of pi. Keep in that form only. Question number 16. You have limit x tends to 0. Cos x upon what? Pi minus x. Now you don't have formula for cosine function. Cos x upon cos x is not 1, remember. We don't have this formula. इसका कोई formula नहीं है. Limit x tends to 0. Cos x upon cos x is 1. Right? We don't have any such formula. There is no formula for cosine function. Only we have for sine and tan. Now here you try directly by applying limit. So I apply the limit denominator. So cos 0. X is placed by 0 upon here pi as it is minus 0 here. What is cos 0? You know 1. This pi as it is. So 1 by pi again here limit to this question number 16. Now let's go to next question 17. This is a really good question. What I'll do, just to write 1 minus form, I'll take minus common from both. So I can rewrite like this. What I did, just taking minus common from both. Now, I already mentioned in the beginning, if you have 1 minus cos x, multiply and divide with the conjugate. So here 1 plus cos x upon 1 plus cos x. Why we did this, you will realize. In any limit question, if you have 1 plus or minus cos or 1 plus or minus sine, we take normally conjugate. Conjugate means multiply and divide with the same expression with opposite sign. Have you realized what's denominator now? What is denominator? A minus b, a plus b, which is a square minus b square. So you have 1 minus cos square, which is sine square. Fine. Agreed? 1 minus cos, 1 plus cos. So what we'll get here? 1 minus cos square. What is 1 minus cos square? That's sine square. This one as it is. Will not do anything with this. We keep till and this one as it is. These two factors I've used, remember. Because I wanted to convert into sine. That's why. Because we don't have formula for cos. Now AB sine में आपको convert करना पड़ेगा. उसके लिए you need to recall one of the formula from the trigo if you remember. Cos, here your minus sine, so I have formula for sine square. If you recall, sine squared x equals to 1 minus cos double angle, the whole upon 2. If I have plus, so I can write use cos square. These are two important formulas from Trigo. So I can place the value of this much. What is that? That is 2 sine square x. Is it? So here I'll placing this much, 2 sine square x. I hope this is clear to you. What I'm trying to tell you, that's clear to you. I have used this double angle formula. So this will get cancelled. So nice question now. So limit x tends to 0, 2 being constant as it is. This is as it is, the other factor of the conjugate. Now cos function is there, so you can apply the limit directly. 2 being constant as it is, 1 plus, what is this? Cos 0. What is cos 0? It is 1. So this gives us here 2 into 2, which is 4. Fine. Question number 18 here. In the 18th question, you have here sine x. So I must have upon x. So I'll set there, remember. This cosine function is not important. So ax plus x into cos x upon b being constant as it is. I have sine x. I need same angle in the denominator. So I'll write upon x. And if I write upon x, I need to write into x. I've set the formula. Which formula? Sine x upon x. Now after doing this, you can see there is a x common in the numerator. Here there is a x. So that x will get cancelled. You should not apply limit directly. If you applied, you will get the 0 by 0 form. So here a plus cos x upon b into sine x upon x. What I did? Taking x common, and I've cancelled with this. X common, cancel with this. Now apply the limit. So if I apply the limit here, a being constant as it is, this is cos 0. Cos 0 is 1 upon limit of sine x upon x is 1. So you have b. Now once you apply the limit, you cannot write here b. So your final limit will be 1 plus a by b. That's your required limit in this 18th question. Right? 19th is too trivial. In 19th question, there is nothing. Just you have to apply the limit. Limit x tends to 0. You have x sec x. So here it is. You can apply limit directly because this tends to 0. So 0, and sec 0. Sec 0 is 1 upon cos 0. So it is just 1. 0 into 1. So limit will be 0. 20th question. So limit x tends to 0 here. Sine ax. See, sine is there, and bx upon ax plus sine bx. Again, sine bx is there. So what we need to do, now. You must have realized after doing so many 19 questions, what we do here, we set the formula. Which formula? Sine x upon x. So here sine ax by ax into ax plus this bx as it is. That's not important for us, remember. Important one is this trigo. Upon this ax as it is. But here you must have the same angle, remember. So sine bx upon, I need to write bx, so I need to write into bx, multiply and dividing by bx. Now once you apply the limit, this will be 1, remember. But here you can see, I can find x common, x common, x common, and it will get cancelled. So I'll write one more step for you. Limit x tends to 0. You are left with sine ax upon ax into a plus b upon what we'll get here, a plus here sine bx upon bx into b. Now almost you are through here. As x tends to 0, with this gives us 1. This also gives us 1. So 1 into a plus b upon a plus here 1 into b. So you'll get the a plus b upon a plus b. So required limit is here 1. Fine. So we keep this much. In the next session, we'll continue next question onwards.